Hello learners, today is yet another day. Good morning to all of you, wherever you are watching me from. In this class, we are going to learn on how to draw or represent statistical data using histograms. So we have a question here. The heights in centimeters of 100 tree seedlings are shown in the table below. Draw a histogram. So in this particular set of question, what we are going to do, we will draw the same table here to represent that. So this being our first question, we will have the height, and we have the frequency. So we have 10 to 19, and we have the frequency is 9. 20 to 29, the frequency is equal to 16. 30 to 39, the frequency is equal to 19. 40 to 49, the frequency is equal to 26. 50 to 59, the frequency is equal to 20. 60 to 69, the frequency is equal to 10. After having that as our frequency, let's draw the table. So we have our table there. So for us to draw a histogram, we now need to get to the next column. The next column, we will determine what we call the class width. We will determine the class width. We will determine the class width, and our class width will be equal to, so class width our class width is equal to, we count from 10 to 19. How many values do we have from 10 to 19? So we have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have 10 values. That is our class width. Then 20 to 29, we still have 10. 30 to 39, we have 10. 40 to 49, we have 10. 50 to 59, we have 10. 60 to 69, we have 10. So when we get that as our class width, since our class width is equal, our class width or our class boundary is equivalent to 10, 10, 10. The whole of it is equal. So this will simplify our work. The reason it is very important to know this is so that you will know under what condition do we use different variables to draw the histogram. So in this particular case, we will now check out on what we call the upper class limits. The upper class limits. And for us to check on the upper class limits, how do we check it? We take the lowest boundary of 10, which is 9.5, to the upper boundary of 19, which is 19.5. So if you subtract 19.5 and 9.5, it will give you a 10. Then we take the lower case of 20.5, which is 19.5. Then the upper boundary of 29 is 29.5. the lower boundary of 30 is 29.5, and the upper boundary of 39 is 39.5. The lower boundary of 40 is equal to 39.5, and the upper boundary of 49 is 49.5. The lower boundary of 50 is 49.5, and the upper boundary of 59 is 59.5. The upper boundary of 60, the lower boundary of 60 is 59.5, and the upper boundary of 69 is 69.5. So when we get that, our table is complete. So in this case, we draw our histogram when the class width is the same. When the class width is constant, we draw the histogram with frequency on the y-axis against the upper class limits. What does that mean? That simply means that this is the format that we use to draw our histogram. We will have the y-axis as the frequency, and we will have our x-axis to be the upper class limits. So that is very, very important to note. We will have this as the class limits, and we will have the frequency on the y-axis against the upper class limits on the x-axis. That is very, very important to note. This condition is when the class width is the same. Now I want us to do this on a graph paper. So we'll have a graph paper here, and on this graph paper, this is where we are going to draw our histogram. So we will draw our histogram like this. So let's have this as we have said, on the x-axis we have the upper class limits, on the y-axis, sorry, I've made a mistake. We should not be starting from 0, but let me correct it here. So this should be broken here. It should not be continuous, it should be broken. Take a note on that. It should be broken, meaning we have not started from 0. And this one will be equal to frequency. So this one we have not started from 0. That is on the x-axis, on the upper class limits. But on the y-axis, we started from 0. So for us now to draw our histogram, we will now write down our upper class limits. We have 9.5 up to 69.5. So we have 9.5. The next one we have 19.5. Let's check out 29.5. 39.5, 49. Yes, we can have a scale of 2, 9.5, 19.5, 29.5. That's a uniform scale. 39.5, 49.5, 59.5. Then last but not the least, we have 69.5. A scale of 2 simply means that, you see, having a difference of 10, it is equal. It is equal. The calibration is okay. Then on the y-axis, we will now have our frequency. And our frequency, starting, the highest frequency we have is 26. So if the highest frequency we have is 26, I think we can use a scale of 2. So we can have 2 here. We can have 4. We can have 6. We can have 8. We can have 10. We can have 12. We can have 14. Let me use a large font so that everyone can see. We can have 16. We can have 18. We have 20. We have 22. We have 24. And we have 26. Let's also add another one, 28. So once we have that, for us now to draw our histogram, we will now draw it from this angle. So from 9.5 to 19.5, our frequency is 9. So our frequency being 9, we will use our ruler, and this is how we go about it. Allow me to use the lead pen. So we are going to take, we will take from 9.5 to 19.5, that is on a frequency of 9. So 9 is at the center between 8 and 10. So we will draw a bar up to this level, a bar up to that level. So I want you to check clearly. So this means 9 is in between 8 and 10. So I will draw until my squares, 1 centimeter squared has got 5 small unit squares. So it will come at the half, the 2.5. So that is how it's going to be like. Then the second bar will be from 19.5 to 29.5, which is 16. 19.5 to 29.5, which is a frequency of 16. So we will get up to 16. We hold that bar like that, then we draw it like that, and it will be like that. Then the next one will be from 29.5 to 39.5 with a frequency of 19. So this other one will be in between 18 and 20. 19 is around there, and 39.5 we will stretch it to mid 18. So it will be around here. Then we will have from 39.5 to 49.5. From 39.5, you can check it out. From 39.5 to 49.5, the frequency is 26. So this will scale up to 26. It will scale up to 26. Once it scales up to 26, that will be equal to that. Then 49.5 to 59.5, that is equal to 20. So this will scale up to 20. Where is 20? This is our 20 here. So it will scale up to 20. This will scale up to 20. Then we, last but not the least, 59.5 to 69.5 will scale up to 10. This one will scale up to 10. So this is our 10 here. So, and this. So once we have that, that is our histogram. We are done drawing our histogram. So this sign you are seeing here, this broken lines here, it means on the x-axis we have not started from 0. So you can now shade your bars. There is no harm shading your bars. You can shade your bars. And that is your histogram. That is how we draw our histogram. And by doing that, you will get your 5 marks. How do you get your 5 marks? You get your 5 marks from filling the table correctly. The second one is drawing the x and the y axis and labeling it correctly. The last marks are from now drawing the histogram itself. And by doing that, you will get your 5 marks. You will get your 5 marks. You get your 5 marks. So having that, I think we can now proceed to our second question. Our second question. So this was our first question. So let's have our second question. Now question number 2. This is question number 2. We have a placard here with question number 2. Draw a histogram for the set of data below. Draw a histogram for the set of data below. The question is being displayed on your screen. So we have the class. And we have the frequency. So we will draw our table very fast. So having that as our table, we have the classes as 100, 150 with a frequency of 160. We have another one, 150 to 200 with a frequency of 120. We have 200 to 300 with a frequency of 380. We have 300 to 400 with a frequency of 240. Last but not the least, we have 400 to 600. 400 to 600 with a frequency of 100. With a frequency of 100. So in this particular question, we said the first thing we determine is the class width. The class width. We determine the class width. So we determine the class width. So in this case, when we determine our class width, our class width is equal to, if you check this clearly, from 100 to 150, that is 50. 150 to 200, that will give us 50. 200 to 300 will give us 100. 300 to 400 will give us 100. 400 to 600 will give us 200. So if you check clearly, our class width is not uniform in this case. Check out here. Here we had 100 to 150 being 50. Here we had 10 to 19 being 10. Why not 9 here? The reason is because from 10 to 19, that class is completely separable or separated from 20 to 29. So you see, this is 19, this is 20. So 100 to 150 is 50. 150 to 200 is 50. That is why the change is like that. So in this particular scenario, when the class width is different, allow me to write that one down. When the class width is different, when class width is varying, when the class width is varying, it keeps on changing, we proceed to find what we call the frequency density. We proceed to find the frequency density. We proceed to find the frequency density. So what is frequency density? It is something that is very easy to determine, and I'm going to teach you how to determine the frequency density. So let's scrutinize our table so that we will be able to simplify this work. So what happens here, for us to find the frequency density, so frequency density, how do we find it? I want you to check. It is frequency divided by class width. It is frequency divided by class width. So we take the frequency, we divide the class width, and once we do that, we have already determined the frequency density. So it is the frequency divided by the class width, and once we do that, we will have determined the frequency density. We have determined the frequency density. So it is frequency divided by class width. So for you to get the class width, what we are going to do, to get the frequency density, we will take 160 divide by 50. It is frequency divided by class width. Once we do that, we will get 3.2. So here we will have 3.2. Then we take the next one, 120 divide by 50. That will give us 2.4. It will give us 2.4. Then we take 100 divide by 380 divide by 100. That will be equal to 3.8. Then 240 divided by 100 is equal to 2.4. Then we have 100 divided by 200. That is equal to 0.5. 100 divided by 200 is equal to 2.5. Then we will now proceed. To determine the upper class boundary or the upper class limits. So we will proceed to determine the upper class limits. So we will proceed to find the upper class limits. Upper class limits. So upper class limits in this case, it is the limits will remain to be 100 to 150. Then the rest will be 150 to 200. Then this one will be 200 to 300. And this other one will be 300 to 400. Then we will have 400 to 500. Why will our limits maintain to be like that? It is because you see this class is not uniform. It is 100 to 150, 150 to 200. So 150 is in two classes. So that is why it will remain like this. So we cannot necessarily be able to have an uppercase or a lowercase. So what we are going to do, having that, we say that class width is varying, we proceed to find the frequency density. So for us now to draw what we are calling the histogram, in this case we will draw a histogram in which frequency density is on the y-axis, frequency density is on the y-axis against class limits, frequency density against class limits, it is against class limits, frequency density against class limits. So that is the format in which we are going to draw this. We said it means that it is not starting from zero, so we can have our graph paper, where we will now draw the structure of this one. So let us have so remember this one we said it is not starting from zero, so let it be like that. So we said that this one is the class limits, in this case it is the class limits, and what we have here is the frequency density. So why is this not the same as this one that we drew? This one we drew the y-axis being the frequency because our class intervals or our class width was equal, it was 10 10 10. But this one we are using frequency density because our class width is varying. You can check and see our class width is varying from 50 50 100 100 200. Even if it is varying with 1, we draw our histogram using frequency density. So what we are now going to do, we will now represent this on a graph paper, and what we are going to do is that we will now get the suitable scale for this. So we can start with 100 here, then let's have 200 here, let's have 300 here, let us have 400 here, let us have 500 here, and a 600 there. So that is this was 600 here, so 600. Let us even mention 800, at least we stretch our scale. So these are the one, the largest or the largest value on frequency density. You can see clearly it is 3.8. So I think we can go with 0.2, 0.4, 0.6, 0.81. Yes, so a scale of 0.2 will work for us. 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 2.4, 2.2, sorry, 2.4, 2.6, 2.8, 3.0, 3.2, 3.4, 3.6. Let's put the last one here. Let me use a different color. 3.8 is at the top, so bakisha kidogo itoke, lakini iko sawa. So we'll start with the first one. From 100 to 150 is frequency density is 3.2. So from 100 to 150, So 100 is here, 200 is here. So definitely 150 is at the center. So from 100 to 150, it is equal to 3.2. So we will draw a bar from 100 to 150, our frequency density being 3.2. Tuichore ifike hapo. If you can see clearly, itafika hapo. Ya pili itakuwa 150 to 200, ambayo itakuwa 2.4. 150 to 200 itafika mpaka kwa 2.4. Itafika hapo. Then we have 200 to 300. 200 to 300, hiyo inatoka hapa mpaka hapa, itakuwa 3.8. 200 to 300 will be equal to 3.8. 200 to 300 will be equal to 3.8. So 3.8 ni yenye tumeona imepanda mpaka huko juu. Sorry for that. Yeah. Making a mistake. Haya, tuende mpaka 3.8. 3.8 ilikuwa imefika hapo juu. You can notice that these bars are not of the same size. Then the next one is 300 to 400, 2.4. 300 to 400, 2.4. 300 to 400, 2.4. Itafika mpaka hapo. Then we have 400 to 600, 0.5. 400 to 600, 0.5. So tutafika 0.4. Between 0.4 and 0.6, that is where 0.5 is. So tutaichorea hapa. That is it. So after we now have this is now our histogram. This will be our histogram. And we can now shade our bars. We can shade our bars. So you can shade our bars, and generally that is how you draw histograms, and that is how you respond to questions based on histograms. If you found this helpful, ensure you subscribe to my YouTube channel, turn on the notification bell so that each and every time I upload a new video, you will be updated with more and more questions related to this. There is still one more question I want us to do on histograms, which is applies a different concept, and I believe once we do that question, all will be well. A question that normally comes in mathematics paper 1 section 2. Section 2 questions are 10-mark questions, and in this particular set of question we are going to answer it. The question is being displayed on your screen. The question reads, the following distribution shows the marks obtained by 82 students in a mathematics test. So the marks are as follows. We have the marks, and we have the frequency. So we have 20 to 29. We have a frequency of 3. We have 30 to 39 with a frequency of 18. We have 40 to 49 with a frequency of 13, 50 to 59 with a frequency of 14, 60 to 69 with a frequency of 17, 70 to 79 with a frequency of 12, 80 to 89 with a frequency of 5. Once we have that, the first question reads, A. State the model class. State the model class. So part A is asking, we state the model class. So for you to state the model class, we said the model class is the class with the highest frequency. It is the class with the highest frequency. So the class with the highest frequency is highest frequency is 18. So the class with the highest frequency is 30 to 39. So our model class will be equal to 30 to 39. We have responded our first question. That was equivalent to 1 mark. That was 1 mark. Part B of our question is asking, calculate to 2 decimal places the mean mark, 4 marks. The mean mark, that is 4 marks. And for us to find the mean mark, we are going to determine the column X. We will determine the column X. And how do we determine the column X? X we said is the class midpoint. X we said is the class midpoint. So we are going to take 20 plus 29, then we divide by 2, and we will get our class midpoint as 24.5. Then we take the second one, 30 plus 39, divide by 2, it will be 34.5. 40 plus 49, divide by 2, it will be 44.5. Then 50 plus 59, divide by 2, it will be equal to 54.5. 60 plus 69, divide by 2 will be equal to 64.5. Then we have 70 plus 79, divide by 2 is equal to 74.5. We have 80 plus 89, divide by 2 is equal to 84.5. So for us to proceed to find the mean, we are going to find FH column. Find the FH column. So we find the FH column. So the FH column, our FH column is going to be F multiplied by H. So it will be 3 multiplied by 24.5, and that will give us 73.5. Then we'll have 18 times 34 that will be equal to 621. The third one will be 13 times 44.5, that will be equal to 578.5. Then we have 14 times 54.5, that is equivalent to 763. Then we have 17 times 64.5, that is equal to 1096.5. Then we have 12 times 74.5, that is equal to 894. We then have 5 times 84.5, that is equivalent to 422.5. After we get that, we are now going to proceed to find our mean. And our mean, as we have said, our mean is equal to sum of fx over sum of f. So we can find our sum of fx here. Sum of fx simply means we will add all the fx here, 73.5 plus 621 plus 578.5 plus 763 plus 1096.5 plus 894 plus 422.5, and we will have 4,449 as the sum of our fx, and the sum of our f is equal to, so what is the sum of our f? You can determine that. It will be 3 plus 18 is 21. 21 plus 13 plus 14 plus 17 plus 12 plus 5, that will give us 82. The sum of f is equal to 82. So for us to find our mean will now be equal to 4,449 divided by 82, and we will end up getting our mean as, if we do that, we will get 4,449 divided by 82. We will proceed to have 54.2 seats. The question reads, calculate to 2 decimal places, so it will be 54.2 seats. So by doing that, you get your 4 marks. So you get the marks from filling the table and the calculation. So that sums up to how many marks? 4 marks. The last question is on finding the difference between the median and the mean. The difference between the median and the mean. So before we find the difference between the median and the mean, we need to find the median. So that was on B Roman 1. On B Roman 2, we are told to find the difference between the median and the mean. So the next we will find number 2 is the median, which we said Q2 is equals to L plus N minus 2, N over 2 minus cumulative frequency over F multiplied by I. So we now need to find the cumulative frequency column. We need to find the cumulative frequency column. So we can add that column here and have our cumulative frequency column here on the same table, that is on the same table. So we can use a blue pen here. Cumulative frequency. Cumulative frequency. Cumulative frequency. So we will start with 3 plus 18 is 21. 21 plus 13 is 34. 34 plus 14 is 48. 48 plus 17 is 65. 65 plus 12 is 77. 77 plus 5 is 82. So our n here is equal to 82. So our n divided by 2, for us to determine the median class, we said it is always n divided by 2. So n divided by 2 is equal to 82 over 2, which is equal to 41. So where 41 is, that is the cumulative frequency class, and because we do not have 41 here, we will take 48 in this case. So we will circle the whole of this class. We will circle that entire class, the 50 to 59 class. That would be our median class. And having that as our median class, we will now proceed to get our median. So from our formula, we've said that Q2, which means the median, is equal to the lower class boundary of 50 is 49.5. Then plus, we can now get n over 2 is equal to 41 minus cumulative frequency above is 34 over the frequency of the median class is 14. Then let's determine the class intervals from 50 to 59. It is 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. So it is 10. That is equal to 10. So our median is equal to 49.5. Be careful here, we are supposed to be using the rules of BODMAS. So we will take 41 minus 34 is equal to 7, divide by 14. Then we multiply by 10 and we will get 5. So our median will be equal to 5 plus 49.5. That will be equal to 54.5. We have already determined our median, which is 54.5. So we now need to proceed to determine the difference between the mean and the median. So between the mean and the median, I can see the median is greater than the mean. So this means that we are going to have, just a minute. Means we are going to have Q2 minus bar H, the greatest minus the smallest. The greatest being 54.5 minus 54.26, and that will give us 54.5 minus 54.26. It will give us 0.24. So our answer is equal to 0.24, and that question gives you 5 marks. The first one was 1 mark, and this one is 4 marks. So a total of 10 marks. That is a KCSE question. Yes. So in question 2, the question is displayed on your screen. The question reads, the diagram below shows a histogram representing the mass of some people in a school. So you have a histogram there, and in that histogram you can see it clearly. It has been drawn on frequency density against the upper class limits. So the first question we asked to prepare a frequency distribution table of the data. So in this case, we are reversing our process from frequency density to frequency and from upper class limits to class limits. So the question, as I've said, it is already being displayed on your screen. So whatever we are going to do in this particular part, we are going to come up with a frequency distribution table. And in this frequency distribution table, part A, we will use the first bar. The first bar, if you check clearly, the frequency density is equal to 8. The frequency density is equal to 8. And the class width is equal to 5.5 minus 0.5. 5.5 minus 0.5, which is equal to 5. So having the frequency density and the class width, we can be able to find what we call the frequency. Remember, we said for us to find the frequency density is equals to frequency over class width. So when we have our frequency density as 8 and we don't have our frequency, we will say f of our class width is 5. So we will cross multiply and get our f is equal to 8 times 5, which is equal to 40. We'll have our first frequency as 40. And our class, when we were drawing that, so our class will be, remember this is the upper class limit and the lower class boundary. So our normal class limit e tulirudisha 0.5, so we will take it back to normal, which is 1, up to this one is the upper of 5, so it is equal to 1 to 5. So we will have that. And we will do the procedure repeatedly for all of them. So the second one, the second bar has a frequency density. It has a frequency density of 10, and it has a class width. It has a class width of 15.5 minus 5.5. 15.5 minus 5.5, that is equivalent to 10. And we said that frequency density is equals to frequency over class width. Frequency over class width. So our frequency density being 10, it is equal to frequency over class width, which is 10. So we will cross multiply and get our frequency as 10 times 10, which is equal to 100. So our frequency is equal to 100, and our class will be from 5.5 being the upper, so it is now going to be 5.5. So it is the lower of seats, so the class will be equal to seats to the upper of 15.5. So normally it is going to be 15. So that will be the case there. Our frequency will be equal to 100 and our class will be equal to 6 to 15. The next one is the third bar. The third bar, whose frequency density, we have the third bar whose frequency density is equal to 4, and the class width is 35.5 minus 15.5. So 35.5 minus 15.5 is equal to 20. So the class width is equal to 20, and we will now proceed to find the frequency, to which the frequency density is equals to frequency over class width, and we will have our frequency density, which is 4, is equal to frequency over 20. So we will cross multiply and get our F is equal to 80, and our class is equal to, so the upper boundary of 15.5 is 16, and the lower boundary of 35.5 is the 35.5 is upper, so normally it will be equal to 35. So that is the frequency and the class. Last but not the least, we have our bar as our bar frequency density as seats. So frequency density here is equal to seats, and now we need to have our class width. Our class width is equal to 50.5 minus 35.5. 50.5 minus 35.5. That is 15. Our class width is equal to 15. And our class width being equal to 15, what we are going to do is that we will now find the frequency, and we said frequency density is equivalent to frequency over class width. So our frequency density being seats is equal to frequency over 15. So frequency is equals to seats times 15. This will give us 15 times 6 is equal to 90. So 15 times 6 being equal to 90, our class will be equal to the 35.5. So this one was 16 to 35. So 35.5 is the lower boundary of 36. So this class will start from 36 to 50. It will start from 36 to 50, and that will be our last. That will be our last class and our last frequency. So we can arrange that in a frequency distribution table. We can arrange that in a frequency distribution table. So let's use this placard here. So if we are asked to arrange that on a frequency distribution table, we will have a table of class and frequency. We have a table of class and frequency. And on this table, this is what we call a frequency distribution table. The table starts from class 1 to 5 with a frequency of 40, then 6 to 15 with a frequency of 100. Then we have 16 to 35 with a frequency of 80. Last but not the least, we have 36 to 50 with a frequency of 90. So we are done. So the next question, so that question will earn you 3 marks. The next part of our question is asking part B. From the table above, the question is on your screen. From the table above, estimate the median class of the pupils to be significant. The mean class, Roman 1, the mean class of the pupil to 3 significant figures. So we are supposed to determine the mean, and for us to find the mean, we now need to find another column of class midpoints. We need to find another column of class midpoints. And in this column, as I've said, the question is displayed on your screen. The question is being displayed on your screen, and in this case we are told to find question B, Roman 1, the mean mass of the pupil to 3 significant figures. The mean mass of the pupil to 3 significant figure. So we are going to find X, column X, in which we will take 1 plus 5, then we divide by 2, and we will get 3. Then we will take 6 plus 15, we divide by 2, we will get 10.5. Then we take 16 plus 35, we divide by 2, we will get 25.5. Then we take 36 plus 50, we divide by 2, we will get 43. Once we get that, for us to get the mean, we need to find another column of fx. We need to find another column of fx. We need to find another column of fx. So fx, we are going to multiply 40 times 3 is equal to 120. Then 10.5 times 100, that is equal to 1050. 100 times 10.5 is equal to 1050. Then we have 25.5 times 80, that is equal to 2040. Then we have 90 times 43 is equal to 3870. So for us to find the mean, we need to find the sum of fx over the sum of f. That will give us the mean. So the sum of fx will be equivalent to 120 plus 1050 plus 2040, 120 plus 1050 plus 2040 plus 3870. So that will give us 7080. Then we add our frequency. When we add our frequency, it will be 40 plus 100 is 140. 140 plus 80 is 220. And 220 plus 90 is equal to 310. 310. So 7080 divided by 310 is equal to 22.8. We have been told to 3 significant figures, so it will be 22.8. Our mean is equal to 22.8. Our mean is equal to 22.8. So we are done with the mean. Let's place that one there. We need it. So the next one, we've been told to find the the median class. Roman 2 is the median class. Roman 2 is the median. And we say that for us to find the median Q2, the formula is L plus n minus 2, n over 2 minus cumulative frequency over F multiplied by I. So for us to do that, we now need to come back here and we add the cumulative frequency column. The cumulative frequency column. The cumulative frequency column. The cumulative frequency column, we will start with 40 plus 100 is 140 plus 80 is 220. 220 plus 90 is 310. So our n is 310. For us to determine our median class, we take 310, we divide by 2, which is n over 2, and 310 divided by 2 will be equal to 155. So for us to determine the median class, we will check where we have the cumulative frequency of 155. And in this case, if you can see clearly, this is 140, so we will take the one with 220 greater than 155. So we can circle this one. We will use that as our median class. So if we are going to use that as our median class, therefore our Q2 will be equal to the lower class boundary of 16 is 15.5 plus n over 2 is 155 minus the cumulative frequency above. Cumulative frequency above is 140 into brackets over the frequency of the class, which is 80, multiplied by the class limits. The class limits from 16 to 35. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So it is equivalent to 20. So our Q2 or our median is 15.5 plus, so we will take 155 minus 140, then we divide by 80, then multiplied by 20, and we have 3.75. 3.75. So our median will be equivalent to 15.5 plus 3.75, and that will be 15.5 plus 3.75, and that will be 19.25. 19.25. So by doing that, you have gotten your answer correct, and that question on median was 3 marks. This one for mean was 3 marks, and the first question, which was asking on creating a frequency distribution table, was that's correct. So let's now solve the last question. The last question is asking how many pupils were 40 kg and above. So you can still see the question on your screen. How many pupils were 40 kgs and above? How many pupils were 40 kgs and above? So you will come to your table. That last question is 1 mark. So this is Roman 2. So we have Roman 3. How many pupils are 40 kgs and above? So tunakuja hapa, wewe unakuja tu hapo unaangalia from your class 40 kgs and above. So if you check clearly, students who are 40 kgs and above, checking out on. So for you to determine the students who are 40 kgs and above, from your graph you will come and read where 40 is, and you can read the frequency density. Then you can use the method we use to convert. Frequency density is equals to frequency over class width. So whatever you read here is your frequency density from that question. Then you subtract the class width, you are going to be able to find the frequency, and you will know the number of students who are 40 kgs and above. Thank you. That marks the end of our lesson, and I'm going to send the assignment on the wall so that you can be able to analyze and respond to questions based on histogram and statistics at large. We still have one part to go, which is we call the frequency polygon. Have a good day. Remember to like, share and subscribe to my YouTube channel. Turn on the notification bell so that you will always be updated each and every time that I upload a new video. Have a good day.